Radical equations. Our first step is to isolate the radical on one side of the equation. So my radical in this one is this square root expression here. So to get that alone on one side of the equation, I'm going to add 8 once to each side of this equation. So that would give me 9 on the right. Now that the radical is isolated, I have to raise each side of the equation to an appropriate exponent that would cause the radical to disappear. Now this one is a square root, which means it has an index number of 2. So to undo that, I would raise to the second power. Now when I do that on the left side, the only thing that happens is the radical and the square root cancel each other out, so that leaves x plus 5. On the right side of the equation, I've got 9 squared, which is 81. Now I just need to continue solving using the opposite operations. So to get x by itself, I would be subtracting 5 once from each side of the equation. And that would give me x is equal to 76. Now before I can say that that's actually a solution to this equation, I do have to check it, because sometimes when I raise both sides of the equation to a power, it produces some extraneous solutions, which are apparent solutions that don't make the original equation true. So I'm going to go back and check it with my original equation. So I'm putting in 76 in place of x. Now when you're checking, you don't move anything across the equal sign ever. So we're just going to simplify the left side of the equation, and if there was anything to simplify on the right, then I would simplify that as well, but there's not. So to simplify, I need to first do what's inside the radical. So 76 plus 5 is 81. Next, I would need to take the square root of 81. A radical is the same thing as an exponent, so that would be 9. Because it's the same as an exponent, that means that it falls in the same place in the order of operations that an exponent would. Then I've got 9 minus 8 equals 1, which is far enough for me to tell that that is in fact true. So that means x equals 76 is a good answer for this equation. Now you're going to do the next one on the Google form and answer it